All right, so this is probably a 2-inch diameter tube, and this thing goes on for a little while. They're getting everything set up for a little bit. July 11th of 07. There you go. Now, you see all that white stuff? That's scale. You see very little bare metal on the inside of this tube. So the story the company tells is that they fired a guy 3 or 4 years before I got there, and he managed the boiler house, and he didn't do a very good job on water treatment. And so, and he was there, he probably ran things for 5 to 7 years. And this is what happens when you ignore your water chemistry for 5 to 7 years. Look at all that crap. Now, occasionally, you'll see a place where it's cracked off and you can see some bare metal. But you see, there you go. See, occasionally. The rest of that stuff, that whole area is coated. That's insulation. Makes it hard. Makes it hard to transfer heat. You're burning all that fuel. Those hot gases are on the outside of that pipe. That pipe's full of water, and you're wanting to generate steam inside that pipe. It's probably some of them are no more than 3-inch diameter. It's something like that.
So they have to do something to dissolve that scale, or they have to resolve it?
What's that?
They have to do something to dissolve that scale?
Yeah, they have to acid clean it. Hydrofluoric acid. Bad stuff. So they have to put a fairly concentrated hydrofluoric acid solution in there and pump it around for, I don't know, 4 to 6 hours. And then they have to clean up all that stuff. And then they're likely to have leaks for a while, because all that acid will eat gaskets and fittings and eat stuff that they don't really want it to eat. So, I mean, what a pain in the rear. But I mean, this was, I don't know, 5 or 6% on boiler efficiency. I mean, you get to a point you have to. I think it was $35,000, $40,000 to clean, and they had 2 of them. They had the north boiler and the south boiler. They're very creative in boiler names. This is north, this is south, you know, we'll just call them that. At some point, they pull this thing out, and you can actually see a little bit of the boiler room around it, you know, you can. So what they do, they open up the steam drum, and then they feed this down the tube, and they feed it all around until it pops out the other end, and then they pull it back out, and they do another one. And there's a lot of different tubes to look at. I guess they look at all of them. I don't really know. If they're just looking for scaling, they don't have any trouble finding scaling. A little problem on focus sometimes.
So when you do like system loss analysis,
I'm sorry.
When you're looking at like the energy loss of the system, does it take into account the pumping losses from all that sale?
This is probably not pumped, because say this water is supplied to the top drum, and in most, well, it depends. Some boilers are called forced circulation, mostly utility boilers. These industrial boilers, it's just water falls by natural circulation. Because also, if you've got water on one side of the tube and water and steam on the other side of the tube, this side is less dense because the steam bubbles take up a fair amount of volume. So you got more weight on this side than you got on this side, and it forces a natural circulation through the system. Now, but utilities do have these that have pumps on them, and yeah, you know, I never thought about that. I would hope a utility would not let a boiler, look at this crap. That's awful. Yeah, they fired that guy. They should have fired that guy. If he's responsible for his water chemistry, and this is what's inside his boiler tubes. Yeah, I was hoping to get to the point where they pull the thing out. I'm not sure where it is. Well, anyway, that's, well, I think I'll pull it out. Well, let's see, look like he's pulling that. Let's see if this is it. Come on. They got a long tube, isn't it? I'm about to get vertigo here. There we go. There. That's the boiler house. Yeah, you can't see much, but that's just the casing, the shell of the boiler.
So for a water tube boiler in the combustion zone, do they build that much pressure in the combustion part of the boiler?
Say that again now. What?
For a water tube boiler, do they build that much pressure in the combustion zone of the boiler, like outside of water tubes?
Okay. Well, no, there's not a lot of pressure. You know, I mean, they can be forced draft. It depends how many fans you got. If you've got like big utility boilers will have a forced draft fan blowing in and an induced draft fan sucking out. And so then the furnace will be what they call kind of balanced pressure. And the pressure is controlled by the capacity of this fan and this fan. If this fan blows more, that'll pressurize it. If this fan pulls more, it'll be negative pressure relative to the environment. But some boilers, smaller boilers, just have a forced draft fan.